Hey everyone, welcome back to the MalChela series. In this episode, we're going to do something a little different. Instead of starting with a file on disk, we're starting with a packet capture. Network traffic is often where malware first shows itself, and today we've got a PCAP that's got some interesting activity baked into it. We're going to use MalChela's TShark integration to work through it in layers, and then jump to MalChela's file miner. Alright, let's get into it. So here I've got a PCAP file. I'm not going to say anything about what's in it yet. We'll let the tools tell that story. We're starting in MalChela GUI with the TShark panel. I've got my PCAP path set, and the first thing I want to do is just look at DNS traffic. I'll set the display filter to DNS and leave the output format on text. I just want to see the raw queries. Okay, so there's a lot here. First, let's throw on a filter for just the DNS query names. Okay, that's a little easier to read. Let me point out a few things based on the queries we're seeing here. At the top, we see api.ipifi.com. This is a public service used to get the host's public IP address. We also see queries going out to zen.spamhouse.org, cbl.abuseat.org, and uceprotect.net. Those are block list services. Now, why would a workstation be querying spam block lists? The answer is it probably isn't doing that on its own. Once the malware checks in and finds its own external IP address via IPify, it then checks that IP against the most common blacklist. That's something malware may do to check whether the infected host's own IP has already been flagged. If it's on a block list, it's a less valuable asset for the attacker. It's recon against itself, essentially. And then down further in the output, you start seeing SRV record lookups for catbomber.net. That's not a typo, that's the actual domain. Things like _LDAP._TCP default first site name, that looks like Active Directory infrastructure naming. So already, just from the DNS, we know this host has been compromised and talking to something it shouldn't be. Now let's follow those HTTP requests and see what actually came across the wire. I'll change the display filter to HTTP request and add two fields, HTTP host and HTTP request full URI. This is going to show me every HTTP request in the capture, along with where it went and what it asked for. Alright, now we're cooking. Let's walk through what we see here. The first line, api.ipifi.org. That's the public IP lookup service we already identified. Next, and this is a big one, look at those requests going to 36.89.106.69. That's a bare IP address being used as an HTTP host. No domain name, just an IP. And look at the URI structure. That looks like a C2 check-in URI. The structure encodes the host name, a unique victim identifier, and what looks like a campaign or module number. This is the infected machine reporting in. You can also see it talking to 203.176.135.102 on port 8082 with a similar URI pattern. Now keep scrolling down. Two files with PNG extensions are being fetched from a bare IP address. No domain name. Just an IP serving up what it wants us to believe are images. Now we're going to find out what those actually are. I'll check the Export Objects checkbox and leave it at the default setting of HTTP, and we'll click Run. If we navigate to View Reports, TShark, we can see our exported files listed here. There's our files, including what looks to be two PNG files that were downloaded from the bare IP address. From here, we'll move into File Miner. In File Miner, we'll browse to our HTTP export directory. Once we select the directory, File Miner will take its first run on the files. It pulls out the name, path, file type, size, SHA-256 hash, what its extension is, and what the inferred extension is. The distinction here is what the file is calling itself versus what the metadata actually indicates. You'll see we have a column here for mismatch, and then we've got our suggested tools column. We also have an option to show mismatches only. When we do that, we can see that the two PNG files that we were looking at earlier are actually executable files. For each of the files, if we wanted to run individual MalChela utilities against them, we could do so utilizing the checkbox. In this case, we've only got two files, so we'll go ahead and select all available tools. When we click Run Selected Tools, we'll see in our top window here, we've got our output from the individual subtools for each file. You'll see that the status on each also changes to green, meaning that that report has been run already. If we go into our View Results, if we wanted to take a closer look at the MalHash report for either of those two files, we can go into our View Reports, then MalHash, and then check the individual reports. In this case, what we're looking at appears to be Emotet Trojan malware. So there you have it. We've gone from a mysterious PCAP file, identified traffic within the PCAP, exported the HTTP objects, and then funneled them into FileMiner to identify file type mismatches, and then continue further with the analysis, eventually identifying the malware strain.